The topic is green button data, a deep dive, and what I am attempting to do is to go over some of those areas of the standard and the data format that seem to be causing a lot of confusion in implementation. Unfortunately, to go into all of the various values and so forth, I'd take up the whole 2-hour conference session. So if you have specific questions once we get done, please feel free to come up to me. I'll be here the rest of the afternoon. And how's this thing work for moving forward?
That one.
That one? Okay. First of all, let's look at what the Green Button Initiative meant and why it was created in 2011 by the Obama administration. It was intended to give home consumers, businesses and personal, access to their energy consumption in a readable, human readable and machine interchangeable form. It was guaranteed to be flexible. It was guaranteed to provide privacy of demographic information for those users, and it was guaranteed to be transmitted in a secure manner. So what is in a data stream that is called Green Button? And if you go to websites, you'll find several times it could be almost any data format, but the standard explicitly says it's an extensible markup language, XML, and an Atom feed, and I'll go into Atom feeds in a minute. But Atom feeds came about in digital electronic publishing. It's an RSS feed if you're familiar with RSS updates to websites. What kind of service does this data support? Typically, when you think of it, you probably think of electricity. However, the standard defines natural gas, water, heat, sewage, rates, and rates, by the way, could be tariffs, it could be taxes, it can be anything. The standard actually defines internet billing and TV license, though those have not been implemented. What's the data source? It's a metering device. Now, when you think of a metering device, you're probably thinking of that meter on your home that rotates, or if it's a digital AMI that does a digital display. Would you believe that your electric car, if you're driving one, is a metering device? By definition in the standard, a metering device is any point that collects and reports energy. So a solar panel that is feeding data back to the grid is a meter. A car that is feeding excess data back to the grid is a meter. Storage batteries are meters. That's the key collection point for the data in a minute that I'm going to show you. It's called a usage point. Energy interval. In what frequency is this data available? Well, first misnomer is I need an AMI meter to get Green Button. Wrong. You can use manual recording devices to turn that data into Green Button capable data streams. So the frequency really depends on how frequently your system retrieves it. We know of some countries that bill customers, believe it or not, once a year. So they ask them to go read their meters every 365 days. Well, that's an interval. But we also know that the standard interval for most AMI meters has now become 15 minutes. The point is, those 15-minute intervals probably could be 5 minutes, 1 minute. Now that we're getting into intelligent meters, it's really the programmable frequency for capturing and retrieving that data. The standard supports all of those. It would support milliseconds, it would support decades. It's all defined in the data stream when you get the data as to the frequency. So why is it not available instantaneously? Well, it has nothing to do with either the data standard or the metering system. It has to do, as Clar said, with the data quality control system of the utilities. The initial implementations that we have seen over the last 2 years is you get an update the next day, every 24 hours after that data has been vetted. You'll see a little later on we have some implementations in Canada and one in California that currently do 4-hour updates and are working on instantaneous every minute updates. So it really is the back-end system that controls the latency of the data. Now, a couple of things to be aware of, and this seems to be an area that's fairly confusing to most implementers. Timestamps in this data stream, whether they are Atom published, updated timestamps, or green button start intervals, are all UTC or Zulu seconds. And the intention is that when you record the data, which should be the start for an interval block, that would be the equivalent UTC timestamp for published. Now, that's not what we're seeing. What we're actually seeing is people are interpreting published as when you ask for the data. And when they send you that feed, that's the published date. That wasn't the intent of the standard. So, why an XML Atom feed? Basically, XML comes with a schema which allows the receiving software to automatically verify that the data is correct in format and content. Required fields are not omitted. Optional fields properly contain the data they want. What the Atom feed does is it allows us to do a multidimensional reference, causing a flat file to become a complex structure. And I'm going to show you in a minute how that works. Furthermore, the standard reduces the development cost for software, because if I talk to utility ABC and XYZ implements the standard, I don't have to customize my third-party interfaces. I might have to customize all of my analytical information and the business aspects of that product, but I don't have to spend time writing new software. There are some tables you have to update, and that's it, but they're the same structure. Furthermore, the schema provides copyright-free and publicly available dictionaries for those schemas. So what isn't a green button data stream? That's pretty simple. Even though a lot of utilities are providing comma-separated value and EDI feeds, some of them are calling the CSV green button. Those do not meet the standard requirements. And you ask, why do they not meet the standard requirements? Comma-separated value fields have no consistency. There's no standard. Even though I can get utilities 5 or 6 to give me spreadsheets, effectively Excel spreadsheets, and they may have the same data. There's no guarantee the units are the same unit-wise, and there's no guarantee that column A is the same in each of those, which is why Clara commented, trying to pull this stuff together from a billing standpoint is an extremely laborious process. Secondly, EDI is a standard that's been around forever. There's 2 issues we found with EDI. Yes, the data dictionaries are standard. The implementation of the contents in those data elements is unique by utility or by area. Furthermore, they frequently say, give me your account number. It's personal identifiable information. Here in home of Equifax in Atlanta just recently got hacked, and you can see how much information's been spread. I personally have had to replace my debit and credit card multiple times because my accounts have been somehow obtained. So I would be willing to bet at least 2 of you in this room could raise your hand if I asked, have you been hacked, knowingly been hacked. It's happening. We have to be much more secure in our privacy, and actually outside the U.S., there are laws requiring that personal identifiable information be protected. One of our implementations is in London, Ontario. And when we first started talking to the Ministry of Energy in Ontario, they made it very clear, you have to meet the Ontario privacy requirement. They actually have a Minister of Privacy. So we're a little behind. We're addressing it with something called Data Guard, if you've heard of that. It's attempting to bring privacy rules in the US up to date to what some of the other countries in the world are. Furthermore, the data structures are flat. They cannot provide complex relationships. And again, the standards don't provide any privacy agreement or security transfer. I can send that as a text file. It doesn't have to be in a SSL certificate secured relationship. So, how do I get my data? Well, I'm going to gloss over this real quick because Claire's already covered it. One is to download my data where I log into my account. If I have an account on my utility's website, download the file, and I can upload it to any third-party analysis. If I'm trying to get solar panels installed, I can send it to the solar cells. The other one is connect my data. The data is the same. It provides an automated process, whereas I, the user, on a one-time basis, authorize access to that data, and the third-party application can get it whenever it's ready. I do not need to reauthorize it. It's protected by access tokens using the OAuth 2.0 standard, and there's a little chart, it's the same one we just saw earlier. I'll go into a little more. So, what are the categories of the data? Let me, I have a pen up here. What's in my hand? Never mind. Sorry, guys. Yeah, there's a pointer. This usage, usage point is the meter collection point, and there's a couple things that come off of this. A summary of all the usage, which is where the billing information has been added. Electric power quality is exclusively electric power quality. If you pull the standard from NASB, this will be called electric power usage summary. That term has been deprecated because we actually have certified people that support water, gas, and electricity. So usage summary is a all-inclusive summary. The meter, the local time parameter, yeah, my battery's dying. Local time parameter allows me to, oh, you got one there, okay. The local time parameter is what allows me to translate that UTC timestamp into a time zone. And it tells me when daylight savings time starts and ends, as well as where I am. Service category says what kind of meter it is. Is it gas? Is it electric? Meter reading and reading type. Reading type tells me, is this an estimated reading? Is it a billable reading? Is this a net meter? Does it have registry capabilities? It really is the characteristics of the meter. The actual data is contained in this interval block with interval readings, and reading quality controls whether it's estimated or not. So in order to get to this 4-minute update or immediate update, the initial read's going to be estimate. Once it's vetted, they can give you that data again, and it's billable. So as you'll see, I've got links, 0 to 1, 1, 0 to many. So how do we relate these links? Well, in a database, that'd be easy. They'd be foreign keys. But we're not running a database. I'm running a data file. So how do I get that? Well, here's an example of what the data looks like. And what we've done is we've wrapped it in an Atom feed and made each of those blocks what are known as Atom entries. The first thing that we do is we have direct links. You'll notice energy usage point is local time parameter. And we have meter reading is reading type. Those were all one-to-one relationships in the other diagram. And then what we end up doing is on all of these others, we have referential links. So how's this really look? And this is going to be hard to read, I'm sorry. Once you get a copy of the PDFs, you may be able to zoom it up, but there's a couple of things I wanted to point out. I have a self and an up, and you'll notice that the up is a category, usage point, and the self has a usage point ID. It's a 1 in this case. And all of these others are related. So effectively, I have a flat file that provides me with a multidimensional complex link to get the other data. The other thing that I wanted to point out, and I'm trying to see where I saw it, this feed has a unique identifier. And the one requirement is that everything uses a ubiquitous ID that is repeatable. It's a UUID type 5 for those of you who are software engineers. There is a basic formula you can use to ensure that it is repeatable. And the reason it has to be repeatable is when you send that updated data, the third party has to know that it's not a new reading, it's an update. So the system requires unique UUIDs and that they be repeatable. Every one of these, it's not shown here, but every one of those entry blocks has to have a UUID. So this is the same diagram you saw a minute ago. And the only thing that was missing in Claire's is that what happens from this authorization is the user can log on either to the third party or to the data custodian. Eventually, you end up asking for authorization, and the third party sends over what's known as an OAuth authorization code request. Once the customer has approved it, they then send over a OAuth token request and get a token. The third party at that point must append that token to every request for the data from that point on. Now, tokens have expiration periods. They also have the ability to be refreshed. So the duration of an access token is dependent on the security policy of the utility. One that I'm familiar with has a 1 hour, and it has to be refreshed, and there's a standard process in the OAuth standard that tells you how to do that. What it means, though, is I, the user, do not have to give you my user ID and password, which if the third party is doing screen scraping, they must get, because what they do is they impersonate you. And the system thinks it's you that is logging on and getting that data from the web portal. That privacy is guaranteed with Green Button data and the Connect My Data interface. It's not required for Download My Data because you must log in and sign on to get that data. So you have self-identified to the utility. So over the last year, one of the things that we discovered was missing from the original energy information is if you were a solar vendor trying to sell your solar system, you need demographic, personal, and identifiable information to know where that house is. Typically, you need it to go over to Google Maps and get a photo so you can figure out what the roof orientation and capacities are. The personal identifiable information element of the energy standard is clear. You cannot do that. So what we have done is we've developed a second schema. Now, this is not published by NASB, so you cannot get a standard that talks about it. It is available on open source, and at the Green Button Alliance, we've got links that can reference you to it. What it does is it comes up with a second namespace. The energy is namespaced ESPI. This is ESPI/retail customer. It provides a second data stream. And the reason I pointed out that UUID is in a minute, you're going to see that it's the common UUID between these two data streams that will allow a third party to tie this material together. Now, this is a very simplified version of that big chart we just looked at with all of the data blocks. And remember, I just said you do an OAuth access. What happens when you do that is two other things are added. One, you have an authorization structure, and you have a subscription. And the subscription controls all usage points to that account. So if you're a commercial or industrial account and you've got multiple buildings on your billing, that subscription gives me access in the Green Button data stream to all of those usage points. So what's the customer retail look like? All of that in red is the new stuff. We have a customer account, customer agreement, service location, which is position point and the meter devices, service suppliers, and pricing structure. Pricing structure is where you get your tariff relation and your energy efficiency program packages. So how do I relate this? The UUID in the service location must be the same as the UUID in a usage point. That way, if I have 5 usage points, I have 5 building locations, and I can tie the demographic information to the data. This merge, aggregation, if you would, is done by the receiving third party. The only thing that the utility has to do is ensure the UUIs are the same for those two. So how do I, as a retail customer, give that third-party access to this retail customer? Well, I have to authorize it, the same way that I authorize access to the energy information. So I, as a retail customer, have control whether I want this solar company to have my demographic information or not. Now, usage summary covers some areas that, how are we doing on time? 10, I got 10. Usage summary has been enhanced to accommodate non-demographic billing information. The way that we have done that is that we actually have come up with categories that are accounting type, debit, credit, generation, distribution, administrative charges. These are outside of the energy data elements that you would see in the interval blocks. We originally started to say, well, we're going to define some categories. That lasted about 3 bills from 4 different utilities, and there is no standardization for how energy distribution, generation, or additional charges are made. So the way that we have defined the billing summary is you provide an open line description that matches whatever you're going to put on that bill. That way, it's customizable to the utility's billing requirements. What it doesn't contain is it doesn't contain the demographic, address, etc. That can be obtained from the retail customer. And actually, Clara and I were speaking about a PDF image. Though the standard doesn't allow that, we certainly could add a link on the retail customer side that would give you that. Now, the advantage of that billing summary is that energy managers can obtain multiple billing from multiple utilities and aggregate that across multiple utilities and buildings. As long as it's the same format, you still have to worry about how utility A versus utility B bills generation or distribution. There really isn't anything that the green button standard can do for that. It's a business-related issue. But at least you get it in a common format, it's digital, and you can do some things without having to hand scribble or set up your own Excel spreadsheet, although you could actually export this stuff into spreadsheets if that's what you wanted. So what are the changes to the published standard that is represented currently in both the certification program and the implementations going on today at utilities? Electric power usage summary, as I said before, has been deprecated. It's been replaced by usage summary. Connect My Data no longer uses OAuth 1 as the standard called for. I actually happen to be the individual who can claim fame for authorization for OAuth 2. I headed the Open SB committee that designed all of that. So if you don't like it, I'm the guy to blame. But the whole purpose of that was, and the reason OAuth 2 came around, if any of you are security people, is most people never implemented OAuth 1. A lot of places stubbed off the verification, and you could get access with bogus certificates or expired certificates. We have now added, for DER capabilities, aggregated and P-node support to the usage point. We've also extended the SB model for energy efficiency and for tariff. And that extension is specifically for California, in that the California PUCs are mandating all of its utilities by December 31st provide DER information as to which one of their customers are on what efficiency, energy efficiency programs, when do they terminate with or without a financial penalty. All of that is now in the standard. It's a combination of the retail customer standard and the SB derived. So a couple of examples, and I'll fly through these pretty quick. If you ask us who to go look at for a certifiable leading green button Connect My implementation, we're going to point you to PG&E in Northern California. Their product is called Share My Data. They initially supported the green button, Download My Data, in 2011, and they launched Share My Data in 2015. Since that launch, they have had 3 major updates. The second update was they added cost to the interval data. The third update was they've added retail customer to that data. The pending update will add the California click-through and Rule 24 DER requirements. Currently, they have 108 reported third-party applications interfacing to Share My Data. Timer. And I'll summarize it by just, you'll have the links. You can go to to our webinar or their system and to their Share My Data website to see some of the documentation. The other one I want to point out is London Hydro. London Hydro actually has a Download My Data certificate for electricity, for natural gas, and for water. Most of the utilities in Canada are hydro-based and do provide water in addition to natural gas and electricity. They currently provide an update in a 3 to 4 hour old mode and have a pilot for instantaneous response. A couple of use cases in Ontario where they have been successful. There is a Thames Valley District School Board that has 165 schools. It actually spans 7 utilities in Ontario other than just London Hydro. And they've been able to use it to measure energy profiles. The London Hydro application is offered to other utilities as an SaaS platform. The other thing I should point out is the London Hydro application is web-based, or cloud-based rather. They use the Google engine, and it was built from the open source code available on GitHub for data custodians. The other implementation we want to talk about is Elmhurst Hospital in Illinois, which is a ComEd customer. They're using ComEd's early Connect My Data application for validating their own energy consumptions. So what's the certification process? Currently, we have Download My Data. It's been available since 2015. We are very close to being able to launch the Data Custodian Connect My Data certification. We're in the final process of cleaning up documentation for an ANSI audit of the UL test facility, at which point all we're waiting for is the ANSI audit itself to be audited, and we'll begin doing Connect My Data certification for data custodians. The cost of that is about $3,500. We want to develop a certification process for third parties. $3,500 is too expensive for a lot of them. They are 3- and 5-man shops a lot, or 1-man shops. What we're looking at doing is UL has a program called Works With for the iPhone and iPad. We're going to model Works With green button third party Connect My Data after that program, and the OpenADE Task Force, which is the body within the UCA IUG organization that defined the Green Button Initiative before it was published by NASB and continues to enhance it, will begin defining what those requirements are very shortly. Any questions?